put it on record. Okay, so the class is being recorded. Okay, just so that you guys know. Okay, sorry. Am I audible?
Yeah.
Okay, thanks. Okay, okay, let's start with I'll just give you an overview what I'm going to talk about in general in this tutorial. So the tools that you need for this class are obviously the language that we're going to use, which is R, and the kind of place where we are going to write these programs is RStudio, which I have asked all of you to download already, install in your computer. Now, why is R used? So it's very useful for data analysis and visualization. And especially for this course, you would have to use some language to visualize what exactly are you doing. Even with the equations, it's good if you can see them. And basically visualization is very important. So that's why we are going to learn this in this tutorial. So I'll quickly go through the layout of RStudio. Like there, you'll see now. Like in a moment, I will open the RStudio, and you'll see different sections in RStudio, which will help you understand what is going on with your program. Okay. Second is how do you even, so you can use RStudio itself to understand what the function does. So I will tell you how you can use so there's documentation available in RStudio itself. We'll talk about the syntax. So syntax is the basically the language with which you're going to write your code. So the syntax differs from different like it differs from language to language. For Python, you might have a different syntax and so on. Okay, I'll have to figure out something with this. Okay, so, and very important when you're learning to code, it's very important to understand the logic. Okay, so I'll come to the logic and what do I mean by pseudocode. I'll just tell you like in a moment. Okay, so I'll just start with what a pseudocode is, or how do you even go about programming. So think of, so your computer cannot compute many things at once. It does one step at a time. So you have to think of a problem and then break it down into smaller executable executable commands. Now for example, I have to figure out some way to allow people. Okay, this meeting might end in between. This is something I was told like just before the meeting, but okay, we'll see if we can extend the session, or I'll send you another link so that you can follow up.
Hello, Tanveen.
Yes.
Can we? We don't have a time limit, so it's fine. Oh, I thought we could maybe do it in Teams, but that's fine.
No, I think I think the time has been extended. Something happened. Okay, fine. Okay, we'll just quickly start with the getting started. We'll just start with the class basically, and you can interrupt me if you have a question, or you can ask me what the hell am I doing with this? Why we are learning this? You can ask me, but just I would like to start with what do you mean by pseudocode. Okay. So now think of a very simple example. For example, when you have to say log in into a website. Okay. So what does the computer do exactly at that time when you have to log in into a say website or even in your system? So what happens is, so can you tell me, like, can you make a, so you have these text boxes which will ask you for the username. Okay.
It's like writing a recipe for
Writing a,
recipe.
yeah, I just want you to think about what goes on at the back end of this. Okay, so you open a website, you put your username. What happens next? What do you think? For example, I put my ID, which is Tanveen.
Validation.
Yes, validation happens. So now we kind of break this whole process into simple steps. Okay, so your program, for example, you're writing a program which has to authenticate the password. Okay, so what you will do is, so first step would be that you actually give the user some space to enter the password. Okay, so you create, say, so you create this text box. Okay, or you create a variable. Variable is something will be, I'll be using very often in the rest of the part of this tutorial. So you kind of create a variable where you save this. Okay, save this username. Okay, it's like some space in the memory with space which will save the username, etc. Okay, I would request all of you to please join on time, because
we can.
yeah,
So we can start.
yeah, I've started. It's just that I have to admit people
For
in the room.
motivation. We just
Yeah.
try to do it like how we do it on
Okay, so the first thing would be to actually create a text box, so say a variable where you save this value. Okay, now the second step would be that you actually, so the
So
computer
that's
would
what,
have
so our
already,
work will be like that. Like from 11 to 5, there is
Others,
no experiment.
press the mute.
yeah, please can you mute
The
yourself?
other kind of work, but
I'm really sorry about the disturbance. Okay, so the first step would be, say you create a variable where you save this username. Okay, and then the computer has to find another, can everybody please mute their mics? Yes, thank you. Yeah, so the second step would be that there's already one username saved in the memory. So the computer would have to actually recall, the actual username, which is somewhere, which is also saved as some variable. Okay, now the third thing, now what would be the third thing that the that the program might have to do? What do you think? What is the next step? Okay, I'll
test whether it matches
exactly
to the one
Validate
that was entered.
exactly. So this is called a logical, yeah. So this is, so there are different kind of operations. Okay, we'll learn about them. So this is like it will validate whether 1 and 2 match or not. Okay, so variable 1 and variable 2, are they equal? It will validate that, and if it is the same, it will display some so even after this, so there could be two cases in this in this scenario. Either the result that you get is that they're not same. Okay, or it could be that they're same. Okay, so in these two cases, what does the program what would you want the program to display? So for instance, you would want the program to display that incorrect username. Okay. And if it is same, you might want it to, you might want to give another text box to fill the password. Okay. Okay. So in the sense, so this is just a very, toy model in a sense. We call it pseudocode because you're not really writing the code, but you're just thinking, how would I even go about writing it if I knew the syntax that the language uses. Okay. So I have talked about a few things here. One is a variable. One is these. So this is called, this is some kind of an operator. Okay. It finds relations between two entities, and if it sees if one, say variable 1 is equal to variable 2, or is it greater than or less than or something like that. So these are operators, and then we will see what we'll use these operators, and then we'll go about to the next step, which is to see. Okay, I'll just skip this thing. We'll just directly go to using R. Okay. So did everyone get what I was talking about? What do I mean by pseudocode? So pseudocode is just, breaking down the process into small executable steps that your computer can do. Now I'll talk about few of the things that you can do in R. Okay. So if everybody has R Studio, we can open that. Okay. Okay, I'll open RStudio now. You guys can also open it. I'll share my screen. Okay, so this is what you see when you open RStudio. Does everyone have RStudio in their computer? I'll take that as a yes. Okay, so when you have to start a new, you have to write a new program. Can you see my cursor? You have to go to this.
Yes.
You select our script. So script is your program basically. Okay. And okay, as you can see, there are 4 components to this. The layout of the whole, RStudio. Here is where you write your program. Here is the console, is where you see the program running. So whenever you run, you might get warning or you might get the answer. For example, I'll show you in a minute. So this space is called global environment. It will show you all the variables, or if you have functions that you have defined for the program, it will, all of those things, all of the materials that you're using in the program, the data will be shown up here. And this space is where you actually see, you can see your files, you can see your plots, packages, and help also. So for any function in R, what you can do is, if you need help with any function, for example, I will be using a function called C. Okay. So a function looks like this. Basically, you have a function name and then you have parentheses. Okay. So for example, I want to know what does this function C do. I will put a question mark. Can you see my screen, what I'm writing?
Yes, yes. So
Okay,
this is
great.
R for, I mean, some Windows, all of them look the same. I mean, because I
I
have
think they all look the same.
Yeah,
So I use Ubuntu. So I think Windows should also look the same.
I
Okay,
am
so
using
for
Windows, it is the same only.
it's the same. Okay, great. So for if you need any help with, what this function does, you put a question mark and then the function name. Okay, and then you press enter. Okay, so now you see on my right hand side, the documentation of R tells you what the function does. Okay, it gives you a description and it has details, and it also has some examples that you can try out and all. Okay, so how do you assign so I talked about variables, right? So for example, I want to set X as I want to store a quantity X, which is say 2. Okay, so there are two ways you can assign a value to a variable in R. You will traditionally see like a back arrow pointing towards X, and then the value of the variable that you want to store. So this is something that you'll see in most of the tutorials you see online. But you can also, what you can do is you can also simply write X equals 2, which is what I prefer. I don't like the arrow thing. And to execute this, so the thing is, I've just written this one statement in my program. Now I want to execute it, so you have to do control enter. So once you execute it, you see that it goes to the console. You can see that X has been assigned value 2, which is visible in the console. And here in your global environment, you see that we have one value called X, which has value 2. Okay, so I would suggest that you keep doing these things along with me so that you also get a practice.
Is there a difference between the both of them, like assigning an arrow or assigning an equal?
So I think somewhere I read that for in some cases the arrow thing works and the equal to sign doesn't work. But in my experience, I've seen that the equal to works well. So so you can use either one of them. Yeah, a lot of people use the arrow only, so it's the same thing. Okay, now second thing is, so it's very important that you make programs which are very which with a lot of comments. It really helps, because if you go back and later on you want to know why did I even write this line of code and you don't remember, it's very important that you put some comments and all. So for putting a comment, you put a hashtag kind of a thing, and then you write this is my first R script. Okay, as simple as that. So what happens with comments is they do not get executed. For example, if I press control enter after this, nothing happens. Okay, so comments do not get executed. So you can actually just put any comment so that you can remember why did you do this. So here I am defining a variable X. Okay, that is what I'm doing. Okay, so so firstly we know how to put comments. Now we know how to define variables. Now I'll come to a very special class of data. So you don't always want to store a data like maybe you want to store a list. Okay, for example, I want to make a list of items, and I'll just so the list of items could be some numbers, say 1 2 5 8 8 9 1 again or something. So I want to store this list of items in a variable. So I will call that variable as say y. Okay, now to store this, I will use the function c that I just told you about. So what you do is you put you put all these values in the function c, and then you press control enter. Okay, now you see on the right hand side in your global environment, it shows that y is a numeric. So the NUM means numeric. So there can be different, kinds of lists. So your list could also consist of just characters, or by characters, I mean ABCD or something like that, or some comma or something like that. But this list contains only elements which are numeric, which are numbers basically. That's why it shows that NUM, and it has 7 elements, which also it shows. So
does
this
indexing on R start from 1?
what?
Does indexing on R start from 1 and not
Yes.
0? Oh,
Yes,
okay.
yes, yeah. So this kind of data type is also known as vector. So just to think of what a vector is, it's like a list, okay? It's like a list, and you can do a lot of things using vectors, okay? For example, what you can do is you can, so you have 2 variables, right? You have X and Y. So what if I multiply X and Y? What would happen? Okay, let's try that. So I do X into Y. Now, okay, for arithmetic operations, you usually use the same kind of, the tools. As in, for addition, you have plus. For subtraction, you have minus. For multiplying, you have asterisk, the star sign. And for division, you use the slash. I'll show that also. So here what I'm doing is I'm trying to multiply 2 different variables. One of them is just a simple variable, okay? And the other one is a vector. So we'll see what happens. Okay. So in my console, it shows that the X multiplies with each element of the vector. So this is something very useful that you'll see while you're coding, okay? While you're making programs. Also, for if you want to, okay, so some of the arithmetic operations that we will
after X multiplied by Y, did you do a control enter?
Yes. So basically, if you want to run any of the statements in your program, you have to do control enter, or else it just it's just a statement. It doesn't run. So the console shows that.
Okay, in order to see in the console, we need to do a control enter.
Yes, exactly.
Okay, and also so this list contains two ones.
Yes.
So like, what exactly does it mean? Is it quite similar to like let's say a grocery list? Like, does it indexes every one, say block A, block B, block C, and then it enters a value in each of them?
Are you talking about the list, or are you talking about the X into Y?
The list.
The list is just it's just a random list. I mean, your list could actually contain. I'll call it vector because list is a different. Is a different data type also. But right now we're just looking at vectors. But this is just a random. You can have all the elements as one. Okay. You can even have one element as, say, here I'm changing it to one element could be hello. Okay. For example, I do this. Okay. Now you see your Y value here. So there's a subtle problem with vectors. Okay. So because I've added one character here, it changes the type of the vector to character. Okay. If you only have numbers, then it's a numeric vector.
So now if you multiply, what happens?
Oh, with that. You can see. So this is my vector, and I do this. Okay. Okay. So now it gives you an error, obviously, because this is not a numeric vector anymore. Okay. Yeah. Okay. So now
I have one question on execution.
Yes.
So you have to place the mouse to the statement where we have to execute before pressing control enter.
Yes. In the same line. You can put it anywhere. I can put it here also. Okay.
Suppose if I need to execute multiple statements, then I have to do.
Okay, so if you want to execute multiple statements, you can either select all of them, say like this. Okay, you select all of them and then press Control Enter. Also, there's one more thing. So because I'm writing all of these commands in different lines, that's why it is treating only that statement, okay, in that line. If you want to write two commands, say I want to also assign a vector z, which is 8 maybe. So you have to put a semicolon between that, okay? And then you do Control Enter. Okay.
Ma'am,
Okay, thank you.
in R, a numeric only represents integers or doubles and floats as well.
No, it represents doubles and floats as well. It's okay. Let's see. For example, you want to see the type of this vector, right? I put one of the, so right now we have integers, right? So you can actually see the type of this vector by writing type of. Type of is again another function because there's a function name and then two brackets. Now I do Control Enter and it shows double. Okay, double is also a type of so you even numerics could be of different types. They could have decimals, they could be just integers. Now if I add, if for example I add another number which is like 6.4, okay, I do Control Enter and then now I see the type of y. Oh, it again shows double. Yeah, it's okay. Yeah, it sometimes shows different. Okay, I'm not sure about this, but I think class might be different. Anyway, so you can actually see the type of, so sometimes it helps, to debug your, so for example, you're seeing some warning during your, while you're running your code. So sometimes this type of, what do you say, function really helps to see, if the values that are going into the program are the ones that you really want in the program or not. Okay, so this is what
What does double mean here?
so it's just a different I'm not sure, but it's just a kind of a numeric.
I mean,
Okay.
any decimal point you can take, float, whatever. So all those
Yes,
things
yes.
represents.
Yeah, float is another kind of number. I mean, you don't really have to go into the details of this unless it's very necessary for your computer. But for now, you just try to get a hang of how do you write a code and what logic do we use in that. I mean, I really don't want to burden all of you with the jargons that we use in while programming and all. But just to get a sense of how just become comfortable with coding. That's all. Okay, and. Okay, so you can also make a vector with with 0 elements. Okay, so for that you can write x equals say you want to make a numeric vector. So numeric is another function, and then as you can see here, it also so when it shows the function, it in that yellow box it shows numeric length equals 0 L. So what it tells you that in this bracket you have to put the length of the vector that you want to create. So for example, I put length as 10. Okay, and I do Control Enter. So now I have a new vector which has 10 elements and all of them are 0. So it's like an empty, it's kind of like an empty vector. Okay. Similarly,
Now can we enter values in X?
yes. Now I'm coming to that. How do you even play around? How do you access these elements inside a list? So we have two lists, right? We have one is X, one is Y. So for example, if I want to access the second element of Y, so you use these square brackets. Okay. So I want to access the second element of Y. So I'll put 2 here and then I'll put Control Enter. So it shows me the second element of that. As somebody had pointed out, the index starts from 1 to 1, 2, 3, 4 like this, okay? Not from 0. In some languages, it starts from 0. Okay, similarly, you can do it for X. I want to know which is the sixth element in X. So I'll put Control Enter and it shows me 0 because all of them are 0 actually. And the sixth element is 0 basically. Okay, now while naming the variables, you can use any of the letters, okay? You can use letters, the dot and underscore in your underscore and this thing. Yeah, letters, numbers, underscore or a dot while you're naming the variables. Okay, can name variables with letters, numbers, underscore and dot. Okay. Next.
Ma'am, is R object oriented?
That all I don't know. I'm sorry. I just use it for whatever I need to.
No, it's not object oriented.
Yeah.
Okay, that then
Thank
makes
you.
sense because then dot must had a special function there.
Okay, I'm not sure about that. Okay, so now one more thing that you can do with this list and with this vector is that, for example, I just want in my vector y, I just want to get the say the elements from 3 to 5. So what you can write, how you can do that is I put y square bracket, I put 3 to 5, okay, and then it kind of creates a sub list, okay, which gives me only elements which are indexed from 3 to 5. You can see in the console it gives me 5, 8, 9. Okay, so this is something that you can easily do in R if you just want very specific, like a sub list you want. Okay, now you can okay, so we have talked about vectors. So there are other kinds of data types such as list and array. So those are different. I will come to them later on. We can try some of the arithmetic operations so that you're just comfortable using R. Okay, so you can actually multiply two vectors. Okay, so I have vector y here. I have vector, say, I'll make vector u, and where is it? Okay, vector u, and vector u is see, I can put 3, 4, 5, 6. Okay, I've put, so the thing is now vector u has 5 elements and vector y has 8 elements. So we can try and see what happens if I add u and v. Okay, oh no, sorry, y and u. So I'll execute this. Now it gives a warning because the lengths of the vector should be same for it to actually do in any computation. So we'll just add 3 more numbers to it. Yeah, now they are of the same length. Now we'll just add these two vectors, and what it does is it takes the element 1 from one vector, adds it to the element 1 of the second vector, and so on. It goes on like that. Similarly, you can do it for multiplication. I will multiply these two. It will do the same thing. It will just multiply the same indexed elements together. If you want to divide them, you can use a slash. Okay. And there is another command, which is this, which is the percentage sign. So what the percentage sign does is it actually gives you a, yeah, what it does is it actually Yeah, what it does is it actually divides one vector from the other vector and then displays the remainder of the two. Okay. And also one more arithmetic operation that you would be using quite often during this course would be the par operator. Okay. So we have vector y. So I will to actually, so we use this hat sign for, setting, making, for example, you want to know the square of the whole vector. So you'll put 2 here and that gives you square of each element. Okay. So these are some of the arithmetic operations that you, so I would really suggest that you try these on your own. You can do to the part 3 or anything. So we have covered the arithmetic operations till now. Now I will come to relational operators. So there are, so while you are, for example, when we were just writing the pseudocode of, that validating our usernames. Okay. So the computer has to kind of match all of these, these values. So now for that also you have certain operators. Okay. One operator is a greater than operator. One operator is a less than operator. Then you have, if you want to see if two quantities or entities are equal, then you put equal. If you want to see if there one of them is greater than or equal to this, you write greater than equal. I mean, it's pretty simple. It's just that you just have to know once, what you are doing exactly. And for example, if you want to see if those two entities are not equal, so for that we use this exclamation sign and a 0. Oh, sorry, and a equal to sign. So the exclamation means not. So it's like not equal to. Okay. So we'll try out some of these. I'll put this in a comment because I don't want to execute it. So I will define my variable 1. Variable 1 equals, say, 23. I say variable 2 equals 64. Okay. And I execute both of these. Okay. Now I want to check whether variable 1 is greater than variable 2. And I'll execute this. So you get that, obviously it's not equal. So variable 1 is not greater than variable 2. So in your console, it shows false. Okay. Similarly, you can do less than. When you do less than, it shows true because it's true. Okay. And similarly, I can just, change my variable 2 to 23. Then I check whether variable 1 is less than or equal to variable 2. And it will obviously show me true because it is equal to the other one. So you can just play around with these kind of relational. And what you can do is, we can also try whether variable 1 is not equal to variable 2. And obviously it will say false because they're equal. Okay. So this is, so we have, if anybody has a doubt, please let me know. If I'm going too fast, that please let me know then also. Okay. So these are relational operators. Okay. Because they talk about the relation of one variable to another variable. You can do similarly with lists also. For example, I make with vectors. For example, I make a vector, say 21. I do C 22. Okay. And obviously I will have to execute these. Okay. And then I do variable 1 not equal to variable 2. Yeah. So what it does is so when you're comparing two lists, what it does is it compares each element and then tells you whether each of these elements are not equal or not. So here the first two elements are same, so that's why it gives false here, and these two elements are not same, that's why it gives true. Sorry, it might be confusing if we put equal equal. Yeah, so it tells that yes, the first elements are equal, which is true. The second elements are not equal, that's why it's false. Okay, now if you want to also test like two different conditions at the same times, for example, you want to test, so I'm making this a little simpler. So I'll put variable 1 equals 2, variable 2 equal to 4, then I define variable 3 equal to say 5, variable 4 equal to say 8. Okay. Okay, so now you want to test, for example, two conditions. So my first condition that I want to test is whether both variable 1 and variable 2 are, are they divisible by 2? So can anyone guess how would I do that using the operators that I've mentioned till now?
Where one mod, I mean, the percentage 2 or where 2 percentage 4.
Yes. So we'll do, so as I mentioned before, percentage tells you what the remainder is when you divide, say, one variable with another variable or any other number. So when I divide variable 1 with 2, what should I get? I should get, oh, I'm so sorry. Okay, so you have to put 2 percentage. Okay. Okay, I'm so sorry. Yeah, I did not execute these commands. That's why it's giving this. Okay. So when I do var1 divided by 2, it does not give a remainder. That means it is divisible by 2. Okay. So the answer here is 0. And yeah, so I want to test whether, both var1 is divisible, var1 and var2 are divisible by 2. So I'll do var2 and I do the percentage sign, I put 2, and this and means that I want both of these, what do you say, to equate to a similar number. Okay, first we will, 1 second, we'll see what happens when we do this. Obviously we'll get 0. So there are some operators which are known as relational operators, logical operators. Okay, I don't know if you have learned about these operators, but so there are 3 logical operators. Okay, one is the ampersand, one is this, this, I don't know what exactly it is called, but it's just like a straight line kind of a thing. And there is another operator, which is the not operator that we have already used. So for and to give true, 1 second. Okay. For example, while you're writing a statement, you want that both the conditions should be, true, or both the conditions should be false. You use the and operator. Okay. So here in our case, we know that both var1 and var2 are divisible by 2. Okay, so we know that, so it will give a true, sorry, Okay, there's some problem with the code. Okay, so in programming, one more thing.
नहीं मेरे पास वो पड़ा है ID कार्ड अपना.
Okay, while we are just waiting for me to become the host again, one thing you can try is you can so there's something called a sequence function in R, which is very useful. For that, you can write it in the chat.
Okay.
In the chat, you can write x, say x is equal to sequence from 0 to 1. So just try this command that I've just written in the chat box. Okay, I am back. Okay, great. Okay, so the thing that I just asked you to try is, for example, you want to create a sequence of numbers from say 0 to 10, and you want them to like, you want, numbers like 0 0.1, 0 0.2, 0 0.3. So basically the steps that you're, the length of the step that you're moving, it would be 0 0.1. So you want to create such a list. So for that, you can use the sequence command. So I want a sequence from 0 to 1, and the increment in the step should be of 0 0.1. And I put control enter. So now I see, if you see my x, it starts from 0, and then you have 0 0.1, 0 0.2. So the first argument that you give is, where do you want your list to start from? Where do you want it to end? And what should be the step length? Similarly, you can create another list like 0 to 100. You want the step length to be 5. Okay, so then if you see it, the variable x shows here that this is the list basically. Okay. Now, okay, now we'll move to the control statements. Okay, So there are many kinds of control statements that you can use. For example, if you want to test whether, for example, we were testing, right, whether this is equal to this or not. So for that, we use the if command, which is, so how do you write the if command? You write if, and you know what is the condition that you want to test. So I want to test whether, say, my variable 1 and variable 2, which I have defined here, whether they're equal. Okay, variable 1 equal to variable 2. Okay, and if these are equal, you want to say print a message that variable 1 is equal to variable 2. Okay, oh yeah, okay, yeah, fine. So the thing is, how do we so this is kind of part of the pseudocode. So when you write if, you have to give a condition, which if the condition, you know, gives the result as true, then whatever is in these curly brackets gets executed. Okay, because right now the variable 1 is not equal to variable 2. This command does not get executed when I run all of these, when I run the if statement. Okay, as you can see in the console, it did not get executed. Now if I make variable 1 equal to variable 2, okay, and now I run this command, it shows variable 1 is equal to variable 2. So this is how, you know, the if statement works. For example, you want to print that, you know, if this condition is not fulfilled, I want my program to display another message. So for that, we will use else in the same line. Okay, so in a sense, it's just, you know, it's just like how you know, make a decision. If this happens, I will do this, else I will go and do that. Okay, so similarly, we'll print here that variable 1 is not equal to variable 2. Okay, now I will execute this command. Before I execute this command, I'll just make them unequal and make sure I execute my command, and then I execute this whole statement, and then I get that, okay, variable 1 is not equal to variable 2. So just remember that after, so when you're using if control statement, after if the control statement comes, the logical operation comes, basically what you want to check. Okay, logical operation comes, and then comes the curly brackets, and inside the curly brackets you put the statement that you want to execute. Okay, and in the else you put, so if the logical operation is untrue, you go to the statement that you want to execute here, the other statement. And for example, if you have many statements that you want to, you know, so you have, for example, many conditions that you want to test. Okay, say I'm saying that if variable 1 is equal to 1, print this command. If I want to say if variable, okay, if I want to say if variable 1 is equal to 2, I want the program to equal to, if the variable 1 is equal to 1, then you wanted to print, say, variable 1 is equal to 2. So if you want to give conditions, we use this statement, this function, sorry, control statement, sorry. Yeah, it's called else if, okay? And if you want to give more of such, okay, say if variable 1 is equal to 1, you print this. If it is equal to variable 2, then you print this. And you can give many options. And at the end, if none of this is true, these conditions are not equating to true, you will choose the else command.
Excuse me, that else we should give immediately after the curly. Is it required?
Yes. I'm not, wait a second, I'm not sure. Okay. We can try actually, even if it is.
The else has to be directly after the curly. Like the first case was correct.
Okay. Yeah, I've switched to Python recently. I've kind of forgotten some of these things. Sorry. Okay.
Can you tell us a little bit about the indentations in these if-else statements and whatever loops we write? How are the indentations supposed to be?
Yeah, so I think RStudio does the indentation on its own. For example, yeah. So R does it on its own, I think so.
I tried to write the else statement below the if statement after the curly brackets, like on the next line. It did not implement it.
Not? Okay.
Yeah, like that.
You wrote it like this? Okay.
Oh,
I'll
okay.
try. I mean, there should be indentation, but
yeah.
I think it should go next to the curly bracket only.
Okay.
So yeah, this is something, one more, this is something that you have to be careful about, that where your curly bracket ends, I think it's important to have the else statement.
Okay.
Help documentation will help. I mean, if you just type help, you'll get all the documentation.
Yeah, that also helps. I think it's just that these are very, peculiar things about this language. I mean, things might change when you use another language, but yeah, you can try out some of these things. Okay, we have. So this is how you can use just the if condition, or if else, or just if and else. Okay. Now, so these are called control statements. Okay, because they kind of decide where the program goes. So for example, in your program, if you have, for example, in the example of the the username authentication, so you actually give the user two choices, right? You either go on this side or you go on this side of the program, as in this side, as in the two options. So it kind of controls how your program flows. Now, in some cases, you have to, do one process over and over. So you kind of have to repeat some of the steps, for which we use loops. Okay. Are people comfortable with whatever I have told till now? Or is there any doubt? And feel free to ask, because this is a tutorial. It's not really like it's not a test right now, because you will get a assignment after this, and you would need to be very clear about what we are doing and how we are doing it. Okay, I think
Can you please explain the sequence once more?
Yes, which the sequence. Okay, the sequence is just that it's a function. So you can write here also. Check the console, and I put enter. So what sequence? So here in the help, you can see that you see this usage, right? Inside this, you have to put where does the, from which number do you want the sequence to start from, till what number, and by what, what is the step that you want it to increase, the increment of the sequence basically. So
basically a list, or whenever I'm getting C, whenever I'm putting the function C, so that means I'm putting discrete values, but in sequence, I'm just defining the endpoints and giving the step, and it is
exactly.
recognizing all of it on its own, right?
Yes, it just takes the starting point of the sequence, the end point of the sequence, and then generates a list which in which the elements increase by this number, the third argument that you give to the function.
So there was this this one point where we found an element, so like y and then square brackets, and then we third brackets, and then we found an element. So if we do that the same with the sequence, will we get the same answer? Like, let's say the third element.
Yeah, we can try. See, so I put x, my x is equal to this sequence of 11 numbers. Okay, now I want to see what is the say the third element of x. I put control enter and it shows me 0.2. Okay, because that's the third element of our list. So this would be very helpful when you are plotting a graph, right? You'll see. Also, if I want like a sub list, for example, I just want some middle elements of the list X, I will do the same thing. I will go, for example, I want elements from index number 3 to 6. I do the same thing here and I get a sub list. Okay. So just remember, in R, whatever number you give, whatever number you want to start from, it would include that number also. Okay. So it would include 0. Yeah. Okay. So this was, these were control statements. Now we are coming to loops. Okay. Are these things clear? If anybody has a doubt, please go ahead. Okay. Okay. So sometimes what happens is you really want to, like go over, for example, here, because I had to, like I had a list, I wanted each of the elements of this list to be multiplied to 2. Okay. For example, this command was not there in R. What would you do? Okay. So for that, you would have to write a for loop. Okay. So okay. So now I create a once. Okay. So now I create a list, another list X, sorry, a vector, and I put the values as these 8 or 20. Okay. This is my new vector X. Now what I want to do is, in this vector, I want all of these elements to be multiplied by 2. Okay. And I want the program to return me a new list where each of these elements are 2 times of whatever they are right now. Okay. So I create an empty list, which I would populate. Okay. Or I can just modify the same list. So you can choose to do either, you can modify the same list, or you can choose to save the result of this operation in a new list. So if you want to do it in a new list, we will have to make an empty list. Okay. So I'm using the numeric this thing, and there's a very useful function which is called length. Okay. So for example, I want to know the length of my, so this is a small list. Okay. It's very easy to count the number of elements in this. If you want to actually know for example, if you have a very big list or a vector, it would really help that R itself computes it. So you put length X control enter, it tells you that the length of the vector is 7. Okay. So here also I am creating, so numeric means that you're creating a vector which has numeric elements, and the length of that vector is equal to, or you can just put directly length x. So it has this, it is like an empty numeric vector which has length same as the vector x. So when I control enter this, I get a y vector which has 7 elements same as x. Okay. Now I want now I want to multiply each of the elements of x to 2. Okay. So it's very so in R they make it very easy because it shows, you know, what exactly do you have to write now. So this is how a for loop is written. Just pay attention to what I'm going to say now. So what you tell your for loop is that for every variable in the vector x, okay, you have to repeat whatever statement that goes in this curly bracket. Okay. So I can, because variable is too long, I can just write I. Okay. So for every I is every element, okay, in vector, in my vector is x. Okay. What the for loop has to do is that it has to take it has to do I into 2, because I just want to multiply each element with 2. And then what it has to do is it has to save each element. Okay. It has to save each of these elements in the y list, the y vector. Okay. So, okay. So it can also print it. If you don't want to save it in y, you can just say print. No, I think. Okay, so there are two ways of actually writing a for loop. So you can say that, so when I write for I in x, that means every element, so I is any element of the, say the list x. Okay. For example, I want I to be the index of, index of the elements in x. I will put 1 to x, 1 to the length of x. Okay, yeah. So what is the length of x? We already know that the length of x is 7. So what it does is it actually starts from index 1. It sees what is there at index 1 of x, and then it multiplies. Okay, I'll just write the code and I'll explain it. I think I'm just confusing you all. So okay. So what I've done right now is, so for every index, so now what would happen inside this, what do you say, the for loop is that, so it has choice from 1 to whatever is the length of x, that is 1 to 7. Okay. So it will go from, say, I will start from 1. So when it is 1, it will assign that the element 1 in the element at index 1 in y is actually element at index 1 in x into 2. Okay. And it would go on doing it till it reaches the length of x. Is that clear, or should I do explain that again?
Yeah, it's clear.
If it is not clear to anybody else, please let me know. I'll say that again, okay? Here, because we already know what length of x is, I can put 7, okay? So I takes all the values from 1 to 7, okay? And what it does is that it starts with 1, say, for example. So so when the loop runs for the first time, I would be equal to 1, okay? So here y1 would be, so we are assigning the value to y1, okay? y1 is currently 0, okay? And what it would do is it would take the value of x of 1 and it would multiply it with 2 and then save it to y of 1, okay? I'll just run this code and you can see what happens, okay? Now we'll see what do we have in y. Okay. So you don't really have to multiply each of them, or I mean, you do not have to write lengthy codes. It just keeps doing it in a loop, okay, till it reaches so whenever, as soon as it reaches 7 is the last number. After that, the loop breaks and you have the result that is shown here in the console. Is that clear?
Yes,
Okay.
yes.
Okay. Now, similarly, you can also use another command which is called while loop. Okay. So while is also a condition. Okay. So while, like we did in the for loop, in while also, you just give a a slightly different condition. So what it means is while this condition is true, keep on just keep on going in loop. Keep on executing the command that I've given. So I'll say while I is less than 8, because I want my code to run till 7. Okay. So while I is less than 8, please run this statement. Okay. So I'm running this command again so as to show that, the while loop actually works. Okay. So what happened to this? Oh, sorry. Yeah, I think I just made a mistake. Sorry. So while you're writing okay, don't write like this. This is a very stupid way of writing. So what you have to do is, okay, so your while loop doesn't know what I is. Okay, that was a mistake. So we start I. So what I want to do is I set a counter. Okay, so I'll set I equals 0. Okay, so sorry, I equals 1, and I say that while I is less than 8, you keep on executing this command. But how do you make sure that it goes to the next index? Okay, so what I'll do is I'll put I equals I plus 1. So what happens is that in every loop, so I started with I equals 1. So it will execute this command first, that it will set y1 equals to twice of x of 1. Okay, and in the next step, what it does it the counter moves to 2. Okay, now the value of I is 2. So it will again check the condition whether I is less than 8. Since 2 is less than 8, it again goes and executes this command, then executes this command. Similarly, it will keep incrementing I till it reaches 8. As soon as it reaches 8, the loop breaks and your computation is over. We'll run this command again. Yeah. So I'll run this while loop and see here I get my y as, the double of x. So this is how loops are created. Is this clear? Okay. Now, as an exercise, let's try writing let's try writing a program. Okay. So I would need you guys to answer these, how do we actually write a, so these are kind of the tools that you're going to use. Like these are very essential to programming in this course. Understanding, so it's very important to understand how to write the control statements, and secondly, how to write loops. So, okay. So now I'll give you a question. So you have to create a program, our program. Okay. That gives the absolute value of the integers in a vector. So can you, so we can, I think you can just go over this problem together. Then you can try the next one that I'll give. Or do you, okay, yeah, okay. So firstly, I will give you a vector, which is, I hope you people understand what absolute value is. For example, I have a number -3, so the absolute value of -3 would be 3. That's all. And for positive numbers, it's the same number. So I give you a vector 1, which is, say, -1, 0, 6, 8, -2, -4, -6. So this is my vector. Now you have to write a program which would give only the absolute value of these elements. So can you think how would we go about doing that? Does anyone have any?
Check the elements are less than 0. If it is less than 0, multiply by -1.
Okay. Yeah, that is one of the options. That, so what would I write? So we'll just try to write a pseudocode, okay, first. So the logic would be, I don't know who answered. So who answered just now? Okay, fine. So what we'll do is, so one of you just said that you look at the logic, okay? So the logic is, we will check if so this is like a pseudocode, okay? Pseudocode is just, code in easy language, in English. You can just change the syntax later on. So if the element in my vector is less than 0, okay, what we'll do is, we will multiply the element with -1. Okay, so this is the logic, but where, how do you display it? Where do you save it? What do we do about that?
We should first have a for loop.
Yes. Why do we have to have a for loop?
Because we have multiple elements in the vector.
Exactly. So you can't be doing this to each element, right? You can't be testing this. So we need to have a for loop. So for every element in the,
or else loop, like not like it's an else statement.
yeah, I'll come to that one second. So for every element in the vector, what I want is that that the program checks if the element in the vector is less than 0. If it is less than 0, what I wanted to do is I wanted to multiply it with -1. Okay, and I think it was Udita, and you said what so what would you put in the else element, else statement?
Else would be just print X.
Yeah, you can either print X or you can, so it depends. Do you want to save the result of this program in a vector, in a new vector? Do you want to create a new list, or do you just want to print it? What do you guys want to do?
Save in a new vector.
You can save it in a new vector. So I will create vector 2, and how should I create this new vector?
Numeric and length vector 1.
Great. Numeric and the length of vector 1. Okay, so I've created vector 2. So what I want to do is, so in the else statement, I'll put that save the element in vec2. But what do I do with this after multiplying it? What do I do with the element which was less than 0? I multiplied the element with -1, but do you think it is complete?
Save it to vector 2.
Yes. Now save the modified element to vector 2. And just remember that this curly bracket should close here. Okay. So this is the pseudocode that you have written. Now you just have to change the syntax of this code to be, readable by, so that it's readable by RStudio. Okay. So I'll just put, okay. So for every element, I'll use say I, okay. I say in the vector, because vec1. So every element in vector 1, what is the condition that I check is whether I is less than 0. Okay. If I is less than 0, it will go and save this. We will multiply I with -1, and we have to save this I into -1 to vector 2. Okay. So I will what's it? So I think there should be some index. So here, I'll tell you what is happening. I think I don't remember. If any one of you remembers it, please let me know. So we have to save this element to say for example, I start with the first element of vector 1. Okay. So I want to save the same in the first, the index 1 of vector 2 also. Okay.
Vec2i.
No, so the thing is, I here represents the element, not the index. Okay. So what here I goes on from, okay, -1, 0, 6, 8, like this. Okay. But if I change my code to for I in 1 to length of vector 1, then I can use then I is the index. I mean, just be very, so this is something very important. Okay. When I write I in vector 1, that means it takes the elements, that is -1, 0, and all those things. When I do I in 1 to the length of vector 1, it actually goes on from index 1, index 2, index 3. It does not take the values. So I'm changing it here. Okay. So then I put here, I would put if vec1 I, okay. I think this is clear now, right? So it's like the ith element in vector 1. If it is less than 0, what you do is you multiply the ith element in vector 1 with -1 and you save it in the ith element of vector 2. Is this clear? Similarly, in the else statement, we'll have the same thing. You just have to save the same, the ith element of vector 2 will be equal to the ith element of vector 1. And this is done.
So we could go do this just if else x is greater than 0 than x, otherwise x into -1.
Yeah, you can do the same thing. Yeah.
Would it be possible to use cbind here instead of using the index?
Yeah, I was thinking cbind is something that appends to the end, right?
Yeah.
It just kind of keeps adding this. Yeah, you can use. But then your numeric would be, you can put it, the length would be equal to 0.
0, yeah.
Yeah. So there's another way of doing it. So what we were doing it initially was, so I can, is it cbind only?
I think, yeah.
Okay. I think, I don't know if, I'm not sure about this. But okay. Yeah. Let's try actually. So I do cbind. So there's another way. What you can do is, now that you have your vector 2 ready. Oh, we should run this code, no? Okay, I run. Oh, okay. Okay, yeah, you'll really have to be careful with the. What happened? Unexpected symbol. Okay, I'm a little bad at this. Oh yeah, sorry. Just be very careful with the syntax. Please don't. So the condition in the whatever, this thing should go inside the bracket, and I think this should work now. Yeah. Just be careful with the brackets and all. Okay. I'll share a tutorial also that I found online. You can just so that you know where to put the brackets, where to end it, and all. Okay. So now our for loop has run successfully. If you see vector 2, we have all the, the absolute value of all the list elements. Now, for example, if I want to add another number to this vec2, okay, let's try if cbind works. I think cbind is used for data frames. Okay, I'll try. So cbind we are doing for vec2. I want to add, say, the value 2. Oh no. No, don't use this. Sorry. It just adds a new column with the values too. So this is with vectors. Now I would like you to try one problem on your own. So now you have to, is this clear? Is this way of writing? Why did I write this way? Is this clear? If you didn't understand, let me know, because I'm going to give you another question, and you'll have to use a loop. Is it clear why I wrote this? Okay. So now you have to create an R program to find the maximum value in a vector. So if you want, you can work in groups for this. Okay. We can have the I don't know how. Okay. Would you like to do it on your own or in a group?
So it should be fine for now.
On your own would be fine. Okay, fine. Okay, I'll give you 5-10 minutes. Then we can. I mean, if you're able to do this, I think you have understood how to do. There might be some problems with the syntax, because even I run into some syntactical errors like this, where I've put the bracket and all. So yeah, you can just see this and try. So we'll take 5 minutes, 5 or 10 minutes. You can try this and let me know if you're comfortable programming. So, okay, we'll meet at 12:50, 52.
Okay.
Hello. Can you just repeat what you gave just now? I just got cut off for a bit.
Yeah, so you have to create an R program. Here is the question. Okay. You have to create an R program to find the maximum value in a vector. Like, so yeah, firstly, obviously you will have to create a vector on your own. And most importantly, you have to think, how will the computer actually know which one is the maximum value? Like, what would be the, smaller steps involved? Because a computer, the program cannot, look at all the values and see, okay, this one is the highest one. Say you have a list of 1,000 elements. How would you even go about knowing which one is the maximum? So it's a difficult question. It's not very easy. So yeah, if you can just come up with the logic also,
I have
or
a
the
logic.
pseudocode. You have the logic. But once again, we'll listen to you after like 5-10 minutes. But
Sure.
yeah,
I
just
don't have the code, but I can guess a logic.
you can guess the logic. Yeah. Okay, great. I mean, logic is very important. And then writing the pseudocode, like how I wrote, for are you able to understand, where do I use a loop, and where do I use a condition, where do I give a conditional statement? Can you write a pseudocode? If you can write a pseudocode, you're I think you know what programming is. So for this, I will write the pseudocode so that you know how did we come up with the for loop and all. If you guys are getting stuck somewhere, let me know. Also, we'll end the class at 1. I think this should be enough for today. Okay, were you guys able to do it? Hello. Should we discuss how do we go about writing this program? All of you who were able to write a program, can you just raise your hand or something so that I know? Even if you are able to write the pseudocode or pseudocode is also good, I would say. So Karthike was able to write. What about others? Okay, a few more people. Okay. What about others? Or you can let me know where are you finding the difficulty? Or if you're seeing some error warning sign or something like that. Okay, what would be the first step to writing the program? Can I randomly ask people? Amanda, what do you think should be the first part to writing the program?
So first of all, we have to create the vector.
Yes, I will create a vector. I'll put vec3. Okay, it could be v3. Yeah, so I've created the vector. Next. What do we do next?
So our aim is to find the maximum value. So what I created the same length. How I proceeded is like, if the ith element is greater than all other elements, then I assign the value. It is not greater than other elements, then I assign 0. It is not working.
Yeah, so you meant that you'll compare one element with all the other elements, right?
Yes.
But yeah, so how do you break that into even smaller steps? Okay, can you tell me what to write? I can.
So I created another vector, so vector 4 of the same length. Then for I in 1 to the length of the vector 3. Then for if the ith element in vector 3 is greater than the vector 3 minus I. That's what I wrote. Can you understand what I say?
So you're saying that you create another vector which saves the some element in say some element of vector 3, and then it compares it with every other element of vector 3, right?
Yes.
Okay, and okay, yeah, this works. And then you keep changing. Then how do you know that? Were you able to execute this, or
no? They show error.
Okay, where did you? Why were you not able to execute it? Were you not able to write it, or?
The error that they said is my flower bracket is unexpected somewhere, but I could not figure it out where it is unexpected. Yeah.
Okay.
Okay.
What
Sorry,
if
one
we
second.
compared
Sorry.
only
Sorry.
first two elements of the vector, and then
And
the
then?
higher one like took the higher one for the next comparison, and then do this process again?
Yes, that also works. I mean, in a sense, that is yes, I mean, that's the correct way of doing it. I think I did not understand Amanda's this thing properly, but I think even that works, but it's just that it's a lengthier process. Like if you take one element and then you compare it to all the other elements, you'll have to do it for all of them. Actually, no. Yeah, try writing it actually and see if you get the answer. Yeah, sorry for the disturbances. Were others able to write? Okay, I'll try, implementing one of these. Let's try Amanda's because I want to see if it works. So we write vec4. How do you want to define vec4?
I defined it as of same length of vector 3.
Okay, why?
Yeah. Then I will take each element from vector 3 and check whether it is greater than all other elements. If it is yes, then I will give the same value of same value in vector 4. If it is not, I will just assign 0. Yeah, I know it's a little messed up.
So you are taking another, in a sense, you're kind of duplicating the vector 3, right?
Yes, right.
Okay, but yeah, but it's more like you really have to compare each element to the, I think, yeah. Think about, like, if you were able to write the pseudo code, yeah, I think that, it would help. Yeah. Okay, we can try.
Okay, maybe we can
yeah.
discuss it later. For the meantime, let's go for the other one. Comparing,
Okay.
Yeah.
Okay. Can we, who was the other person? Can you go ahead with your, can you tell me what your idea was?
Yeah, so I was saying that we just compare in the first two elements and we see which one is higher.
Okay, how do you do that? I mean, what should I do? What should I write?
Okay, first of all, we'll need a for loop.
Okay.
For
every element.
For every element in
vec3.
Vec3.
Vec3, right? Okay.
Yeah. So we check I is greater than I plus 1.
Okay. So for I, I'll write every element. I'll replace it with I. Okay. So you will check if I
is
greater
than I plus 1.
I plus 1. Okay. If it is greater than I plus 1, what do you do?
Then save that value.
Save that value, right? Where would you save that value?
We should create another vector.
Exactly.
Vec4 numeric length 1.
Okay, we'll save it in vec4 and now we'll create vec4. Okay, which is numeric. You can directly put 1 also. Yeah, I mean, write 1. Okay, so if statement says that, you save that value in vec4. If I is greater than 1, do you want to put an else or anything else? I mean, what do you do after this?
If it's less than 1, then we'll have to save I plus 1.
Okay. Else save I plus 1 in vec4.
Yeah.
Okay.
Although we don't have this case here, but in case I and I plus 1 are equal,
yeah,
then in that case we can specify either should be saved in 1.
Okay, great. So you have kind of covered all the what do you say, the cases. It could either be greater than this or it could be equal to this. Okay. Did you try running this code?
No, I just came up with the pseudocode. I'm trying the code now.
Okay, fine. Yeah, I think yeah, this should be good. Okay. Does anyone else have any other ideas on how to write, so the thing is, you can use different kind of logics. It's just that some might use some other maybe more number of steps, or it could be entirely different from this kind of an approach. Does anyone else have any other idea?
I have a question, Tanveen.
Yeah.
So in the given case, like for I in vec3,
Hmm.
just comparing I to like one greater, like one other number, but not the whole vector, right?
Yeah, but since you're going in a, what do you say? Oh yeah, good point. Yeah, but in this, in a sense, for example, if I compare 23 and 1, it will take up 23, right? It will save 23 in my vec4. Then it would compare. So it has to kind of compare. Oh yeah, good point. Thank you. So it has to compare the value in vec4 with the next element.
Yeah, and has to do that until it gets the.
Exactly. Yeah. So you'll have to change the code that way. So for that, so you save the value in vec4. Now you have to compare. So you have to put. So what we can do here is we just put the assign the value of. So instead of making vec4 empty number, we assign the value of, vec3, the ith, sorry, the first this thing of vec3, this. Okay, so I've put, in a sense, I've assigned that vec4 is now 23, and what it will do is it will check if here if vec4 is greater than the next number, which is 2, and if that number is greater than vec4, it will save that value in vec4, or else it would save the I plus 1th element in vec4. Okay, then again it will go to say the element number. So I becomes 2 in the next loop. It will check whether vec4, the new vec4, is greater than 3. If it is greater than 3, then yeah. Yeah, so the vec4 remains the same in that sense. Yeah. Is this clear?
Should it not increment I in the next step, like, and go on like a while sort of loop?
So it will automatically do that. So with the for loop, you don't really have to tell it to, increment. So every time the loop runs, I increases by 1.
Okay.
Yeah. In a while loop, you have to tell.
Okay.
So it will go over all the elements till it finds the end of vec3.
Okay. So this is going to be for I in length of.
Yes, exactly. I'm not sure how do you write the other, how do you choose the element, and then, so I think this is, for now you can use this. Length of vec3. Yeah. So if you do that, you'll have to put vec, that it becomes the index, sorry, yeah, the I plus 1th element of vec3. So it compares with that. Similarly here. Yeah. Okay, is this okay? Yeah, it's already 1:08.
Can we try executing this?
Yeah, we can try. Let's see. Vec4, if vec4 is greater than Just remember to put the brackets. So in a sense, here we are assuming that vec4 is yeah. In a sense, here we are assuming that vec4 is the highest one, and then we keep changing. So here I've changed it a little bit, that if so vec3 ith plus 1, if it is greater than vec4, okay, then my vec4 becomes this. Okay, else it doesn't change. So we don't need this. Yeah. Let's try. So I execute this, and I execute this. What did I do?
The else part is missing, no? In if else.
No, so else is not, it's not mandatory to have else. You just want to, wait a second.
I mean, what will it do when vec4 is like this is not true, like if it's false?
So vec4 remains the same in a sense. I mean, so you don't change vec4 at all.
Like vec4 is equals to vec4 in that case, I think.
I mean, then, that's I can write like, vec4 equals vec4, but that doesn't, true, false, missing value where true or false is needed. So vec4 is this. What is the value of vec4? Oh, it actually gave it actually worked somehow. Yeah, it gives the value 90, which is correct, but I don't know where. Yeah. Okay, I'll look into this. Even I don't know where is the problem. This one. Okay, let's try else. H4 equals. Put it in the curly bracket. Yeah, I don't think it's the else statement. Okay, I'll see. Even I'm not sure where is the problem. Yeah, although I get the value of vec4 as the highest one. Yeah, the maximum one. Okay. Cool. I think we're sort of done with the class. Okay, do you guys have any other doubt? I think we should, we can take it up in the next class if something else is very cool. Like more explanation is needed.
Okay, thank you.
Okay, yeah.